exercise 4 in chapter 3. This one essentially asks us to take in a bunch of doubles similar to what we did in exercise 3 and think of them as distances between two cities, and then find sum of all of those distances, the minimum distance, the maximum distance, and the mean. So we'll start by creating our vector of double. We call it distances. And we'll do the same reading as we did before. So for double D, standard Cn into D, and we can skip this part here, and then we'll say distances dot push back D. And so at this point we have all of the values read in, but I'd like to introduce another couple of things. So we're going to do standard, so we're going to have a double min distance, and what we're going to set it to is actually something a little bit unusual. We're set to standard numeric limit of double, and we're going to actually set it to max, and I'm going to show you why that's the case in a bit. This is going to look a little bit weird. You probably haven't seen this before. The book hasn't introduced it, but I'd like to introduce you to this thing here. Numeric limits effectively is the ability to figure out what is the maximum or the minimum value that can be represented. And so we'll also say double max distance is equal to standard numeric limits of double min. And you'll see that these are opposite of what we have over there. We'll also have our double total distance, set it to 0, and double mean is also going to be 0. And I like to do these at the beginning so it's clear what we're developing for. So now we can go ahead and iterate for the elements inside of the collection. So for double D in distances, and we're going to do a couple of things. So first, if D is greater than the minimum distance, then what we're going to do is we're going to say min distance gets D. So effectively what we're saying is if we found a distance that's greater, we're going to set it to that. We're also going to do the same thing over here. If D is less than max distance, it's greater than, if D is, less than min distance. If D is greater than max distance, we're going to then say max distance gets D. Then we're going to do the following. We're going to say total distance. We're going to add to that. And we don't need to do anything for the mean, because for the mean, what we'll be able to do is we'll use afterwards the average. So once we finish that, now we can do the mean. Mean is just the number of elements that we have, so distances dot size divided by the total distance. Or sorry, total distance divided by distances dot size. That's right. So total distance divided by distances dot size. And so that's our mean, right? So that's the total that we have divided by that. And now we can go ahead and print it out. So standard cout max is going to wind up, let's print it pretty like this. Max distance min distance and we'll do over here as well on a new line. We'll say total distance is going to be total distance, and we'll say mean distance is going to wind up being and that is it. And the one thing I'd like to add is just a small input here to make sure that we prompt the user appropriately so that it doesn't come as a complete surprise. Standard cout, please enter distances between cities, control D to finish. And that should be it. Now let's go ahead and run the program and make sure that it does the right thing. So let's go ahead and enter the distances. We'll say first it was 23, 5, 98, 2, 5, 34. Let's do an actual double, so 22.8 and also 122.9. And I think that should be it. We do Control D, and there's our max. That looks right. Here's our min. That looks right. Total distance looks about right. And mean looks right as well. And so this concludes this exercise. Ship it.